Okay, topic 5, part 2. We are now solving quadratics with leading coefficients. Solving is something we've done. We did it with factoring greatest common factor first. We did it with factoring their basic trinomial first, and now we're doing it again with factoring with a leading coefficient. So you're going to take the same steps as we did before. You want to make sure it's set equal to 0, then you factor, set each factor equal to 0, then you solve and check your answers. So when we're solving, it's already set equal to 0, so now we factor. Okay, factoring is the more difficult part of this. Solving is a little easier, but let's get through it. So here we have a leading coefficient that cannot be factored out. So I multiply 3 times negative 16, that's negative 48. What multiplies to negative 48? That adds to 2. I know I have 6 and negative 8, or negative 6 and positive 8. So that's a positive 2. It's going to be this one. Okay, so I have, we're going to split this to be negative 6h plus 8h. You have the minus 16 and the 3h squared. We're going to group it. Here we can take out a 3h. We're left with h minus 2. Here we can take out an 8. We're left with h minus 2. Now they both have an h minus 2, so I can take that out. Oops. H minus 2, and I'm left with 3h plus 8. From there, we set each factor equal to 0, so I have h minus 2 equals 0, 3h plus 8 equals 0, and I solve. I add the 2, so h equals 2. On this side, minus the 8. 3h equals negative 8, divide by 3, h equals negative 8/3. Okay. Next problem, right here. First step, set equal to 0. I'm not equal to 0 here, so I subtract the 2. So I have 15, n squared minus n minus 2 equals 0. Now I factor. I have leading coefficient, nothing can be factored out. So 15 times negative 2 is negative 30. What multiplies to negative 30? That adds to give me negative 1. So let's see, it's either negative 6 and 5 or negative 5 and 6. I have to add to a negative 1, so negative 6 and 5. So negative 6n plus 5n, you have the minus 2 and the 15n squared. Now we group it. Here, let's see, 15 and 6, I can take out a 3 and an n. 15 divided by 3 is 5. I have 1 n left over there. 6 divided by 3 is 2. On this side, plus 1, and I have a 5n minus 2. 3n plus 1, I can take that out. And what's left is 5n minus 2. Once I'm factored, I set each factor equal to 0. And I solve. Minus the 1, so 3n equals negative 1. Divide by 3, so n equals negative 1/3. Here, add the 2. 5n equals 2. Divide by 5, n equals 2/5. And there you go. Alright, so there are 2 examples. Let's see, what do I have next? A couple more examples. So this one, we are not equal to 0. We need to be. So I need to add the 4r over and minus the 6. So I have 10r squared. Negative 21r plus 4r is negative 17r minus 6 equals 0. There is no greatest common factor. I almost said 2, but 2 doesn't go into 17, so no common factor. I multiply. 10 times negative 6 is negative 60. Now what multiplies to give us negative 60, that adds to give us negative 17. I know it's not going to be 1 and 60, so I'm going to try 2 and 30. That's not, so negative 2 and 30 or 2 and negative 30, that's not going to work. 3 and 20, so negative 3 and 20 or 3 and a negative 20. Add to get negative 17, so right there, 3 and negative 20. So plus 3r minus 20r. I have the 10r squared and the minus 6. Group it. Here, I take out an r. I'm left with 10r plus 3. Here, negative 20r and negative 6, I have a negative 2. Negative 20 divided by 2 is 10r. Negative 6 divided by negative 2 is plus 3. Now, they both have a 10r plus 3, so 10r plus 3 and r minus 2 equals 0. Set each one equal to 0. Here, minus the 3. 10r equals negative 3, so r equals negative 3/10. Add the 2, r equals 2. So, those are the 2. Okay. Over here, 9z squared. Add the 6z over, minus the 15 equals 0. Okay, and that's just adding this over to that side and minus the 15 over there. Okay, now it's equal to 0. We factor. Is there a greatest common factor? Yes, there is this time. There's a 3. 3 goes into 9 3 times. 3 goes into 6 2 times. And 3 goes into 15 5 times. Alright, we still have to factor the inside. Still has a leading coefficient. So you've got to go through your steps. 3 times negative 5 is negative 15. What multiplies to give us negative 15? That adds to give us 2. Let's see, 5 and negative 3 or negative 5 and positive 3? Positive 2, so that's 5 and negative 3. So plus 5z minus 3z. Okay, group that. Can take out a z. I'm left with 3z plus 5. Here, they're both negative, so I'm going to take out a negative 1. And that'll give me a positive 3z and a positive 5. Now they both have a 3z plus 5, so I'm going to take that out. What I'm left with is z minus 1. Now, you also have this 3 on the outside, so that can stay there, and that equals 0. Now, that is a factor, but because there's no variable, 3 is not going to affect whether or not this equals 0. So, I mean, you can write 3 equals 0, but that's not true, so that really has no bearing on the problem. Okay? It's really when 3z plus 5 equals 0, because it has a variable, or z minus 1 equals 0. Okay, so you do need a 3 there in terms of factoring it, but when you're going to solve to set it equal to 0, doesn't really affect it. Okay, with the other two, u minus 5. So I have 3z equals negative 5, divide by 3, z equals negative 5/3, and add the 1, so z equals 1. So there are the 2. Okay, and I believe that's it. These are your U tries. So you have 2 of them to try, and we'll go over tomorrow.